So first, if it doesn't tell you what kind of a polygon it is, then count the sides. 1, 2, 3, 4, 5, 6, 7, 8. So it is an octagon and is 8, meaning there are 8 sides and 8 interior angles. And the area of this regular octagon will be the area of 8 triangles, which is 8 of these. So we need to know the yellow triangle's base and height, and that will do it. But how do we find the base and the height of this triangle? We need to know the measures of these angles. So this segment that's 2 feet, this is an apothem. It's from the center to the midpoint of a side. Therefore, for a yellow triangle, the distance from the center to the midpoint of the side will be 2 feet. We need to know the base of this yellow triangle. We know its height is 2. So this problem boils down to, can we find the base of this triangle, which is the length of a side of this regular octagon? To do that, we're going to have to know the angles in this triangle, and we're going to use just half of it because we can use right triangle trigonometry, either special rights or SOHCAHTOA. So let's focus on just one half of our yellow triangle so that we have a right triangle. We know this is 90 degrees, but how many degrees will this angle be and this angle be? So remember, you have 2 options for finding these angles. One is to think about the center, which is a 360-degree rotation. All the way around is 360 degrees. And since there are 8 sides, there will be 8 of these triangles. So for this central angle, its measure will be 360 divided by 8. You can count them. 1, 2, 3, 4, 5, 6, 7, 8. So that will give us the measure of this top yellow central angle, and we'll have to cut it in half to get the angle of our right triangle. 360 divided by 8 is 45 degrees. Each of these angles in the center are 45. And then when we cut that 45-degree angle in half, we get 22.5 degrees. Since this angle and this angle have to add up to 90, so that the other 90 gives you the 180, 90 minus 22.5 is 67.5 degrees. Now, if you prefer, there's another way of finding these angles of our right triangle. And we talked about that in our first video for this assignment. And that was to find the measure of each interior angle of the regular polygon. And we could have found the measure of each exterior angle by doing 360 divided by the number of angles, which is 8. So this is a 45-degree angle on the outside. And if that's 45, then the interior is 180 minus 45, which is 135 degrees. So if every interior angle is 135, then to cut that in half right here, 135 divided by 2 is 67.5. Finally, your last option for finding the measures of these acute angles of our right triangle is, again, to find the measure of an interior angle, but instead of doing it the last way, by finding the sum of all interior angles, which is 180 times n minus 2, and n is the number of sides. So that gives us 180 times 6, which is 1080, and then divide that by 8, because if that's the sum of all the interior angles, then each one will be this total divided by 8. And that's 135 degrees for the interior. So we cut it in half, again, we get 67.5. Okay, my preferred way is to do the 360 divided by the number of sides, 8, which gave us 45 degrees for this entire central angle, and taking the 45 and dividing it by 2. But it doesn't matter how you do it, one of those 3 ways will help you to find these angles. Now we can find the base. So remember where we were at. The area of this entire polygon is 8 triangles, the yellow triangles. And each triangle is 1/2 times the base times the height. From the center to the side, to the midpoint of a side, that perpendicular segment is the height. So that was 2. To find the base, we need to find this dimension here. So in our right triangle, we can find the length of half of that base and then multiply it by 2 to get the full base of the yellow triangle. Let's call the base of this green triangle x. And let's use the 22.5 degree angle over here in SOHCAHTOA. So if we're at this part of the green triangle, 22.5 degrees, x is opposite, and 2, that's not the hypotenuse. The hypotenuse is over here. We don't know that one. If we're at 22.5 degrees, x is opposite, and 2 is adjacent. O and A is OA. SOHCAHTOA makes this a tangent problem. So tangent of 22.5 degrees is equal to the opposite side divided by the adjacent side. If we multiply both sides times 2, then 2 times the left side equals 2 times the right side, which cancels out divided by 2. X is 2 tangent of 22.5. But that's just this dimension to get the entire base, because remember, for our yellow triangle, we need the entire length of that side. We'll take our x value and multiply it by 2. So the base of our triangle is 2 of these x's, 2 times that, or in other words, 4 tangent of 22.5. And now we have what we needed. All right, the area of the entire octagon is the area of 8 triangles. Each triangle is 1/2 times the base times the height, and the base is 4 tangent of 22.5 degrees, and the height is 2. So let's see, 1/2 times 4 is 2, and then 2 times this 2 is 4, and 4 times 8 is 32. So there's the exact answer. And if we round it to the nearest tenth, then we'd enter this into our calculator and give an approximate answer. The area is approximately 13.3 square feet.